the second video about graphing polynomial functions. In this video, we'll look at x and y intercepts and how that affects the graph in the middle of the graph. Let's get started. I first want to focus on the x-intercepts. Okay? The x-intercepts is where the graph crosses the x-axis, which happens when the y values are 0. So that's the same as solving the equation of 0 is equal to x minus 2 times x plus 3 squared. Okay. Now, this is in a factored form, and so I can use all of my tools about solving equations and the zero product property when it's already factored. If it isn't factored, my first step would then be to get to factor it so that I could then put y equal to 0 and then use the zero product property. But this is already factored for me, which is pretty nice. So what number minus 2 is 0? And that's x equals 2, because 2 minus 2 equals 0, which means at 2, I have a 0. Now looking at this factor, what number plus 3 equals 0? Well, let's see here. Negative 3 plus 3 is 0. Okay, so I have a 0 also at negative 3. But I notice here that I have different things happening at each of these zeros. So right here, I have it kind of touching it or bouncing off of the x-axis, whereas over here, I have it like going straight through or crossing the x-axis. So different things are happening here. Okay, and this connects with the idea we've discussed previously with the ideas of multiplicities. Okay, so x equals 2 is a 0, and it's only one of the zeros. So x equals 2 is a 0 with multiplicity of 1. And so at this case, it's going to go through. Something about the multiplicity being 1 will make it cross the x-axis. Okay, if x equals 3 here, it's like touching or bouncing, and that's because it's a multiplicity of 2. And you can see that right here with the exponent. Okay, so let's look at some other powers of these same factors and try to see at what multiplicities we have it crossing, and at what multiplicity we have it bouncing. So if I have this second power, okay, I notice that at both negative 3 and at positive 2, it's touching in both cases. Something like the multiplicity of 2 or this exponent of 2 means it's going to be bouncing or kind of hitting that and going back up. If I change this to third power, okay, let's look at this now. So at this 0 right here, at x equals negative 3, coming from this factor, it's crossing through, but kind of doing it with a little bend in it. Okay, so multiplicity of 3 has it crossing, and the multiplicity of 2 is still bouncing. Okay, let's look at multiplicity of 4, and let's try to draw a conclusion. So if I change this to a multiplicity of 4 instead, okay, it's now bouncing. Okay, making this multiplicity of, let's say, 5. Okay, that changed it a lot actually. At x equals 2, it's crossing at 5. So it looks like when the multiplicity, this exponent here, is odd, it's going to cross the x-axis. When the multiplicity is even, it's going to bounce off the x-axis. Now let's shift our focus to the y-intercept. So the y-intercept is where the graph will cross the y-axis, which happens when x equals 0. Okay, so I can think about finding when f of x is 0, or when the x value equals 0. And so you just plug in 0 in for all the x's, okay? And if it's in an expanded form like this, it's super easy because all of these terms go to 0, and you have this constant term becomes your y-intercept. Okay, let's check that out in an expanded form, and notice that this number out here is always going to be that x-intercept, right? Let's keep it kind of here, right? 2 or 3, right? Or if I change these numbers even and make it something very different, I still have, remember what this is over here, I always get this constant number to be my x-intercept. So if it's in a factored form though, let's look at one of those. Now in a factored form, it's not as easy to tell, right? But again, the idea is that it happens when the x value is 0. So I find f of 0 by plugging in 0 into all of my x's. And figuring out that the y-intercept will be 4. So if it's in a factored form, then you'll need to plug 0 into all the x's and compute for where the y-intercept is going to be. Okay, this video is about graphing polynomial functions, looking at the x-intercepts where y is equal to 0, and looking at the y-intercepts where x equals 0. Thank you so much for watching.